life. So without further ado, let's get things started and bring out our first finalist who is going to present and wow you with her innovation. So I'd like to welcome from Sioux Falls, South Dakota, let's bring out Miss Allie. How are you?
Good. I'm really nervous, though.
You should not be nervous. Don't be nervous. Yeah. I'm going to hand this to you. We saw this yesterday. You have a great thing to share, so good luck. Don't be nervous.
All right.
Have fun.
Thank you. Nosocomophobia, or fear of hospitals, is a surprisingly common fear, especially for kids. When children are staying in and/or are visiting the hospital and have anesthesia, or are there for some kind of respiratory reasons, testing can be hard. Sometimes they need to use the same boring medical device like a spirometer or peak flow meter up to 12 times a day, taking 3 tests per set. This can get boring fast. That's why I came up with the idea to make it a little more fun. Introducing the new and improved blow dart spirometer. To use my co-spirometer, the patient draws a target onto the 3M whiteboard. They then take in a deep breath and hold it in for a few seconds while a nurse holds down the red readings button. The patient then exhales as hard and as fast as they can. This will shoot the dart. You will then find that your readings are recorded on the laptop in PSI and liters per second. This is what I like to call bringing the incentive back into the incentive spirometer. My innovation is able to take the respiratory readings hospitals need and uses 7 3M products in its design. The blow dart spirometer works using a venturi tube, which starts at a larger diameter and ends at a smaller diameter, causing a change in pressure as the air is forced into a smaller space. My sensor is connected through flexible tubing to these 2 diameters and is able to read the difference in voltage, which is then translated into PSI and liters per second. Looking at this reading, currently my spirometer is able to closely measure a peak flow measurement. My first prototype was made out of PVC with only 90-degree angle transitions using these mathematical principles. My hypothesis or goal was to improve this design to create a device that would make spirometry more fun, as well as see if changing and testing the diameter differences would have an effect on the readings. I decided through research to improve my design by designing and 3D printing new venturi tubes that would minimize reverse airflow. I was able to come up with 4 new venturi designs with different diameter differences, however keeping the ideal angles constant at 25 degrees and 8 degrees, so I could measure how that affected my readings to choose my best design. My first testing process began at a local science center using a compressor and pump that were used to launch paper rockets. I was able to use 3M adhesive tape to connect my venturi tube to this system and create an airtight seal. I realized, however, that this system was putting out too high of a pressure at over 15 psi for my commercial peak flow meter, which was my control. Therefore, I had to scrap that idea and start over. My second testing process that I designed around a compressed air cannon similar to a potato cannon. Upon building that, I found out fast that although it was extremely fun to shoot the darts with, the valve that released the air needed a PSI of at least 10 to work well, which is once again too high compared to the PSI of a human's breath. So I kept looking for ideas. My third and final testing process that I engineered I like to call Rocky because it consists of a wooden bench turned upside down with a high volume, low PSI kayak pump attached. On top of this, 25 pounds of rocks sit balanced on the handles to weigh it down when lifted. Gravity and the weight of the rocks is on my constant, and I was able to lift the handles and drop the rock weight attached to pump a low PSI gust of air through my tube or peak flow meter. It wasn't perfect or fancy, but it worked at the correct PSI levels I needed to successfully test my tubes. I was also able to connect a commercial peak flow meter to the end of each of my venturi tubes, so I could measure with both on each drop. Each of these graphs shows the liters per second read on my tube, compared to a peak flow meter control on 15 tests. I was surprised to find out that each of my tubes worked really well as for tracking up and down with the commercial peak flow meter on each drop. I was also amazed at what I could do without the precision testing equipment that professionals use. I think this proves my previous hypothesis. All the readings were good, and so were the points of deviation, so this led me to use a Pew matrix to aid in my decision-making process. After a long time of consideration, I was finally able to choose the design of the purple venturi as my final tube. It had a good design, took good readings, was easy to use, and shot the dart perfectly. I decided that it would be my final and reprinted it in spacesuit blue. I ran an additional set of tests to verify that the color change didn't change my design's capabilities. But I was not finished innovating yet, as I created a net out of a 3M safety vest attached to dowels on 3D printed cubes. The net sits on the hospital overbed table and serves as a dart catch to prevent contamination. The 3D printed customizable whiteboard target with the 3M adhesive surface sits nicely inside this net, and both the net and the target attached to the overbed table by 3M command strips. My venturi tube attaches to my dart tube using 3M adhesive and can be decorated by my patients using 3M tape stickers. I hope my innovation inspires people to design new kid-based medical equipment for children everywhere. I would like to thank 3M, Discovery Education, and my mentor, Dr. Chris Toonhorst, and everybody else for helping me inspire others with my innovation. Thanks. Yay, I did it.
Congratulations, you did it. Great work. Allie, really, really outstanding work. I can see you put in a lot of time and effort.
Thank you.
When you were going through this process, I guess there's two parts of this. Number one, did you contact any, say, medical professionals along the way to ask for their guidance and input? And what did you learn? And then did you also test this with any children, for example, to see what the response was?
Before I created my first prototype, I met with 2 respiratory therapists, specifically children's respiratory therapists, who said it would be a great idea and that they would be able to use it for the kids who are probably more stubborn and didn't want to use this innovation, or the past uses. And it would also make it more fun for the kids who are really bored, or the kids who are scared of the medical equipment, then it will also help them feel more comfortable around it. I also met with a Venturi expert so that they verified my angle differences on the tubes to show that it would minimize reverse airflow. And they verified my design because saying it was good, which is always a good thing. And I've learned a lot through that.
Thank you.
Allie, fantastic. Quick question. Now, you've spent some time in the hospitals, and there's a lot of devices in there. Have you considered other devices that you may incentivize to increase patient compliance?
I would like to probably, if people were to design new devices that would be more kid-friendly, then probably shots, because those always make me nervous, and they're the worst. So if anything was to be designed that would make it more fun for kids or have an incentive, then it would probably be that, because I didn't know.
Allie, congratulations, bravo,
Thank you.
what a beautiful job. So it got me thinking just now when you were talking about shots. In your research, did you learn about any other current devices that have modifications to them that are accomplishing the same thing for children or adults that create more incentive for processes like this?
The only one that I've found that is sort of similar to my device that I have is kind of like it was like a potato shooter gun, but that one didn't take readings. It only was for toy use, and it was only to get them to take therapy afterwards, but this would also be able to take the readings, and shooting darts is probably more fun than marshmallows, because you can't eat them after you've shot them.
And the other part is that the child gets to draw their own picture and
Right,
then do that,
yeah.
which is another layer of fun in there. So congratulations.
Yeah, and they can decorate their Venturi tube as well.
So let me ask about the tube thing. Did you 3D print those yourself?
Yes. Each of these designs I've 3D printed, and I also 3D designed them on Autodesk Inventor Professional 2017. And yeah, I got the 3D printer after I made my first prototype, as you can see, because I wouldn't make that as my first prototype because it kind of stinks. But yeah.
Well, did someone help you with that? I mean, because that's just really a cool to go from that to the medical device to the 3D printed one. You just kind of play with the design?
Well, actually, I was having trouble kind of figuring out how to 3D design online. I've learned a little bit through school, but I also had to go to YouTube a lot to figure out some of the designs, to figure out how to make it rotate and make it a full 3D thing and not just a sketch, which is what I was sort of making. So yeah.
Allie, it's been a joy watching you through the whole challenge. Congratulations on this. What's your next step with this? What are you going to do next in the development, or what are your plans with this innovation?
Well, currently my innovation only measures peak flow, which is kind of like what this measures, or the amount of air that flows through the tube in 1 second, the maximum amount of air that you can blow out. And I would like it in the future to measure a full exhalation and inhalation loop, so you'd be able to exhale and inhale, and it would show the whole graph. But right now, currently, it only measures this. I would also like to test it on the precision test equipment if I had more time, because who wouldn't want to test it on official equipment? It's always good to be official.
Great job. It's really been a thrill to watch you through these past couple days. I have a couple questions that are more qualitative in nature. You talk a lot about fun and boring, and children who are sick, we certainly want to do whatever we can to help them to maximize the fun. Did you conduct any research on how to measure fun or get any qualitative feedback?
Well, actually, my first Venturi tube, it only shot the dart about 10 feet, and I was like, oh, yay, it shot the dart. And then my new tubes, they shoot the dart like over 50 feet, and I'm like, yeah! So it's like way better than it was before, and I guess if that's enough measure for fun, then yeah.
Great answer.
Thank you.
You did. Awesome. Nice job.
Thank you.
Just stay here for 1 second.
Oh, okay.
So I was just thinking, because first of all, I love this. And he said, what other extensions, like if you can do anything with needles, because I'm like, oh, immediately, like there we go. So as I'm sitting there listening to you, because I understand about half of what you guys talk about, so I'm just sitting there thinking, and I'm like, what if you combine the two? Like yours, and then I thought, so I'm like, I'm gonna tell Allie, and then I'm like, wait a second, that's just a tranquilizer gun at that point. So don't use that idea, go with this, all right? Another round of applause.
Thank you.